One thing is certain, and that is technology is really at work here with the Charleston County government, the Public Works Department, and the Transportation Sales Tax Program. We're really into the areas that are important, like rural counties, roads, and it's all being done as a consequence of something that lasts for a long time. It's a paving, it's called Pervious. We can do more roads, spend fewer dollars, and the opportunities abound. We'll be back in just a moment, so please don't go away. Welcome back to our program. We're going to be talking with an engineer who's responsible for putting some of this project together. It's a very interesting thing that he's done here. And what they're using is asphalt or some grade of asphalt that you're trying to create. But Trey is an engineer, and he's responsible for the design and testing of projects like this, and he's helped us to create in his lab this notion of pervious. Is that the idea?
That's right.
Asphalt. What is that?
So it's a concept of an open graded, which means an aggregate structure, a rock that has all the same size, so it allows the water to flow through it when it's compacted.
Where did this idea come from? Usually we see pavements like the one I saw coming in here off of Joseph White, and that was perfectly fine, wasn't it? But it must be expensive. Is that the idea?
That is true. There's a couple different things going on there. So the porous asphalt allows the water to drain through, so you don't have to have as much interruption of the local landscape for stormwater drainage needs. And this mix allows us to use local materials and hopefully make it cheaper.
Now, your work at Mead West Vaco was to put this kind of aggregate together. And as a consequence, we're sort of trying it out here today, I assume.
That's correct.
When will a project like this be finished, and what are your expectations?
Right, well, we'll finish, this being a short road, will be finished today, the construction of it, but it'll take monitoring. We'll be looking at it over the next couple years to see how it holds up, and working with Sanders Brothers in Charleston County to look at other targets where we can maybe try the same concept.
Can you give us some ideas to the ingredient that was involved? What did you put together? I heard trees or some kind of element like that.
Right, well, obviously people from the area know Mead West Vaco from the paper production. Along with that, there's a lot of byproducts and tall oil and different chemicals that come off the trees, and we look for different applications. Asphalt's one of the applications that we put these oils into, and that chemical goes in and modifies the actual asphalt, the black liquid, the glue that holds the road together.
And that makes it a lot different from the regular paving and the ingredients that's in the sidewalk, rather the type of material that we use today.
Correct. Typically the asphalt would need to be heated to high temperatures above 300 Fahrenheit to be laid down. With this chemical in there, we're able to lay this down at much cooler temperatures and use cheaper asphalt in this mix because of that.
How did you get to this point, and how long did it take you?
Well, there's been a lot of people doing this work at Mead West Vaco before me. We started making Evotherm, our warm mix chemical, to allow you to make cooler temperatures about 10 years ago. So there's those people that have been in the Charleston area for 20, 30 years at our lab that have been working on these chemicals.
Now, what is the life of pervious asphalting and paving? How long will it be around, and can it withstand rain and all of those kinds of elements that it's going to be facing?
Right, well there is a question of the lifetime of the porous asphalt, the pervious pavements. We hope to last 10 years or more. We'll see. Typically in the low volume road applications like we have here, you're going to have a longer lifespan, so hopefully it'll be a really sustainable product for Charleston County. A lot of times you're going to see longer life with the porous. It's designed for specific applications to get the stormwater off. It doesn't have quite as much structural component, but it's still going to be a long performing mix.
So I'm seeing as we're talking that there's the possibility for the rain to go through.
Yes, ma'am.
So it's porous, as you just said, and as the rain comes down and other elements, where does that water go? Does it soak it up, or does it push it out? Where does it go?
Right, so there's 8 inches of stone base underneath that's put down underneath the road, and that allows for the rain to drain through the asphalt and to sit until the ground soaks it up in a major storm event. that's the way it's designed to collect the water and then let it seep out slowly.
And what's in it for West Vaco? Tell us why, besides being a good partner in the community.
Right. Well, it's exciting for us to get to be a partner in our own local community when we sell products, all over the world. And that's fun for us to have roads locally, and it's fun to hopefully develop a model like with what we're doing with Charleston County, where we can go to another county and say, hey, if you pave these local rural roads that are dirt right now with this, we use this solution, this porous asphalt, then this can be a model for you. This can streamline your process of paving these roads and make it more cost effective for your taxpayers.
Have there been other times when you've gone to cities and counties or other places around the country and you've tried, I'm assuming this is not the first time you've tried this out?
Well, there are other porous asphalt applications. The interstates throughout South Carolina have a version of this called open graded friction course. It's put down at a much thinner level just to get the rainwater to sheet off the road. Mm-hmm. This is really the first county that we've really worked with in this way to look at the rural roads and try to come up with a solution. So it is a first in some sense.
I didn't realize either that you have a lab there at Meade West Vaco.
Right,
and that's where you work. And that's where you create these things.
That's correct. Yeah, a lot of people just see the paper plant and don't realize what all goes on there. It's a state-of-the-art testing facility, not only for asphalt, but for oil field chemicals, carbon, and other industries as well. So.
Well, this technology is being tested today and probably for a long time, and it's good to know that we have friends in the community and partners in the community who help us put together ways that our citizens will know that they're getting their money's worth. This is about the transportation sales tax program, and we at the county want to make sure that the citizens get the best bang for their dollar. And it sounds like they're going to.
Yeah, and that's exciting. Hopefully the citizens will see these projects coming along and will be excited about it as well. So.
Thank you so much, Trey.
Thank you.
Matthew Fountain is an engineer, and he's with the Charleston County Public Works Department. He's one of those gentlemen who's going to be responsible for trying out this business of pervious asphalting and paving. And it seems to me that the county really would be involved in something like this because of our new rural road project.
Sure, it's a combination of two things. It's one, cost in terms of without this option to control stormwater, many of those roads, there is no way to pave them with a traditional road section.
Is it cost effective, do you think?
It is. Basically, our option for those roads is to go out and obtain enough right-of-way to put ditches in, to have drainage easements. In many of the locations in the rural area, there just is not that space available.
And so that's not used or won't be necessary in the future as long as you're doing the pervious kind of paving.
Exactly.
Yeah, and so that's working for the county. So that means to me that the cost must have been reduced or will be reduced to a fair extent.
Yes, we no longer have the costs associated with obtaining that extra land. We don't have to worry about impacting grand trees, live oaks, things like that. And we also don't have the same expenses with permitting and engineering for this type of application.
What is it about this kind of paving that you find to be very critical to the work we're doing in public works for the various road systems throughout the county?
Basically, one of our major goals for public works is to bring an improved level of road maintenance to the rural sections of the county, especially to the dirt roads. And this allows us to make that happen for those citizens.
Now, once we've tested this product that's been made by Meade West Vaco, will we then go from there to paving all the roads, or is there going to be a waiting period? Or when can we expect to see the roads besides this one, the test road, throughout the community?
Sure, and this road is sort of our third version of our test road program. We started with two roads over in the Mount Pleasant side of the county, Judge Road and Call Lane, and have tried different approaches to this pervious asphalt mix. With this road, we're now performing a method that will help bring the costs down on that.
Yes.
And allow us to then expand into those areas of the county. So hopefully we'll see a pretty quick turnaround on that.
Is there a maintenance issue here?
This is actually something we're doing to decrease our maintenance costs. Is with a dirt road, we have to run motor graders over the road, keep the roads clean. Every time it rains, you're looking at potholes, other problems. With these roads, the actual day-to-day maintenance is very minimal. It's only once every 10 or so years we'll come in and do major maintenance work.
One of the things that I'm interested in, and Eric Adams, who is with Charleston County Public Works and the Transportation Sales Tax Program, he was telling me that through the GIS system, they're able to map and to identify most county roads and also be able to determine when they will need maintenance. And so I imagine all of this fits into that mix as well. What are you hoping overall to get out of this kind of paving?
Long term, we're looking at this as a great tool for stormwater management of paved road surfaces in Charleston County. Those regulations are becoming more and more stringent, and the county is working very hard to maintain the quality of life that comes with our excellent water systems. In terms of paving these roads, we'd like to combine now multiple roads into one paving project, which will help bring those costs down further and allow us to pave an entire area of dirt roads at a time.
I did talk a little while in the last interview about the kinds of materials that are used in generating, and I know Westvaco is doing this already in their labs, but it seems like this kind of approach will not only allow us to move quicker and save dollars and that kind of thing, but it sounds like it's got a shelf life that's fairly good.
It does. It definitely increases our speed of permitting. Permitting is very minor. The engineering design is minor. One of our biggest delays is generally acquiring enough property to be able to put these roads in. So all of that is no longer a concern, which will make our process much faster. And they do have an excellent shelf life for rural road applications. It's a wonderful term.
Give us a 1, 2, 3 on the rural road program, and one of the reasons why you're using this approach with Pervious, but just a little bit about that program.
Okay, the County Rural Road Program, which is focused on county dirt roads, really is what we're especially worried about. The county's bringing those into its regular maintenance system in large numbers right now. We have approximately 380 dirt roads that we maintain. Normally we're doing a monthly to quarterly maintenance of those roads, and we're working road by road to try to improve the surface of those roads to an asphalt level or a pavement level in order to reduce those maintenance costs. This material will allow us to bring pavement to communities where we would never have been able to bring traditional asphalt paving.
You've seen the test road today, and I'm wondering, are you satisfied with what you're seeing?
Yes, I think the road looks great. As I mentioned earlier, that we should be able to have car and truck traffic on it today, which is another great plus for this program, that it minimizes the disruption to the residents on these roads as we come through and pave them.
Tell me, what has the county done to make this kind of paving cost effective?
What the county's really focused on is trying to take the pervious pavement and find a way to bring it down to where it's a similar cost of a standard asphalt paving section. And we actually have worked through 2 previous pilot roads, Judge Road and Call Lane. And now what we did with this road, based on our experience with those roads, was we worked with Westvaco and with Sanders Brothers Construction to try to develop a less expensive custom Charleston County asphalt mix, we call it, for this road. Instead of using sort of a standard DOT mix, we said, well, what are the needs of the county and how can we look to save money to meet those needs?
Thank you so much. Now talking with Eric Adams, and he is an engineer with Charleston County government, and he is in the transportation development area or department. And this gentleman sort of leads all of this process as it regards technology that we're using in pervious paving. And it's been cost effective, and the technology is awesome, and you're going to hear from him and some others about it. Eric, thank you for talking with us.
Sure.
This is really an interesting way to pave a road. How does it differ from the traditional way?
Well, there's not a lot of difference in the construction. The difference is the materials that we're putting down and the bedding. So what we have here is a rock bed course that's about 8 inches that acts as a reservoir to hold the water that flows through the surface of the asphalt or the pervious pavement. A typical asphalt would be sealed and wouldn't allow water through. So the difference here is the rainwater will just flow right through the surface of the road.
And is that how it differs from the traditional paving? Very much so, I would imagine.
Yes,
Yeah.
ma'am. The actual performance of the material is much different. From an environmental perspective, it's very beneficial.
I imagine that it took a lot of partnering with various organizations.
Yes,
And I
ma'am.
know Sanders Brothers was involved, and then DOT must have been involved to some extent, and then Charleston County Public Works was involved, and all of those folks to ensure. How long did that take?
Well, the county's been interested in pervious pavement for the last about 3 years or so. We've made a couple of attempts and completed a couple projects But the cost was too high, so we knew we had to find a way to lower the cost to do it on a larger scale. So at that point, we reached out to an industry leader, who's Midwest Vaco, their chemical products, and asked them what their thoughts were on how we could lower the mix. We also reached out to contractors to get their opinion on how can we lower the cost of production of the mix. And that's where we ended up with the partnering effort.
There's an assumption here that these roads have never been touched by pavement or paving of any kind. And I asked you about that is because I was wondering if you had a road that had already been paved with the traditional asphalt, wouldn't you have to remove all of that before you were able to put this down? As opposed to the traditional asphalt, we would just pave over it, a new coat, would we not?
Right. You know, asphalt that's already in place, we cover that with our resurfacing program, where we'll come in and maintain it and overlay it. This product will be for dirt roads, improving dirt roads to a paved surface.
And that seems to be working. I noticed that everybody here today is pretty excited about what they've seen, this one trial or effort to see whether or not it works. What's the one thing about it that you like?
Well, the potential is what we really like. We don't know how how far it can go, but it has the potential to expand to all of our 300, almost 400 earth roads that we currently maintain. You know, maintenance cost with a dirt road, you continually have to go out and blade it. You have public safety concerns on you need to keep the road open. Some roads are in low-lying environments where you have potential emergency response issues with people who need emergency response if the road's not passable. School buses can't go down some roads when we have bad weather. So this product has the potential for us to improve those roads to a paved surface and improve the quality of life of citizens.
I know that we're sort of testing the whole idea here today, and the assumption is that we're going to be paving rural roads in Charleston County, and there are a lot of them.
Yes, ma'am.
Do you have any idea as to approximate number that we need to pave? And do you think that this product is going to stand the test, and as a consequence we'll be able to use it?
Yes, it definitely has the potential. Again, this is a pilot project, so we're going through a bit of a learning curve, and we're trying things to make it more economical so that we can apply it on a larger scale to all the roads, dirt roads in the county.
We're going to take a look at this a little bit later, the road that's been paved with the pervious material. But I'm wondering whether or not people are going to be able to accept the idea that it is porous, but it doesn't mean that it's going to fall apart. Why not?
It's designed that way. Basically, you know, we've worked with Midwest Vaco, done the lab testing to prove that the structure of the pavement will hold together, but it will also has voids in it that allows the water to pass through.
Eric, tell us again, why is this cost efficient?
It's more cost effective from an overall project perspective. There's some roads that we have in the county because of drainage and because of trees and because of right-of-way, there's no way we could traditionally construct those to a paved surface. This solution allows that opportunity on some roads that we may never have been able to improve otherwise.
Well, I wanted to ask you quickly about recycling. I know that there are some materials that we've used in the traditional pavings that came as a result of that. Are we using material that's brand new here, or is it something that we're just recycling?
In this application, it's all new materials because we're trying to reduce the amount of variables. So we're trying to control the production. So we want to make sure the materials perform. But it does have the potential to use recycled materials.
I want you to show me. I'm from Missouri. You got to show me. So we're going to take a look at that in just a second. Let's do that.
All right.
Eric, as we talked earlier, I want you to show us how all of this works, especially the idea of this material being pervious. And I imagine that's one of the main qualities of it as well. Tell us how that works. And my other question has to do with rain and water. Show us.
Okay. So to give you an idea the differences, I want to show you at first what a traditional hot mix asphalt. So our driveways are traditional hot mix asphalt. And we've got Buck Dukes here. He's going to show us how water, when it hits a traditional asphalt, how it performs. So as you can see, it stays on top and it ends up running off, and we call that stormwater runoff. So if that were rain, it would run off and we'd have to direct it somewhere to a drainage outfall. If we walk over here to the section where we've paved the pervious pavement, we can see the difference in performance. So as the water hits the surface, you can see it does not stay on the surface. You get a little bit of splashing, but the water disappears into the base.
Where does it go?
So below the surface layer, we've got 8 inches of rock, which we call the reservoir. It'll stay there temporarily, and then it perks into the soil.
I'm thinking that we ought to call this rain resistant of some way. In some ways it is. But I can't understand where that water goes. Is it soaked into the material that makes the pervious paving come about? Or does it go underneath? And I also see fine rocks here. And what's the job of the rocks?
The easiest way to describe it is it's similar to a septic tank leaching field, where the water goes out over a rock bed and just kind of what we call percolates into the soil and recharges the groundwater table. Just like rainwater would in a forest, it perks down into the soil, gets filtered through, goes into the water table. And the purpose of the rocks is...
why are they there?
It's to act as a temporary reservoir. So right when the water goes through, it perks through there, and it also provides the stability for the road. And that's its main purpose, is to provide the stability for the asphalt so that cars and trucks can travel.
Now there's no wetness that's in this area. If you put rain, or if rain comes or water is used, as we did as a demonstration, apparently the water doesn't affect it on top or underneath. Is that true?
Well, the application of pervious pavement, the soil conditions have to be right. So we can't do it in an area that's not well draining soils. Otherwise, the water doesn't have any place to go. But because this is a granular sandy area, which most of rural Charleston County is, it will perk, and the application can be very wide spread throughout the county because of the soil conditions that we have.
I'm looking at this right now and it looks like black popcorn. Is it?
It does look similar to that, and that's the structure of it. You know, it's different. A typical hot mix would be very well compacted and solid structure. The intent of this design is to have the voids so that the water can flow through it.
Does it get poured in a way that it sticks together?
Yeah, it gets placed in a layer about 2.5 inches thick, and it's slightly compacted, not to fully compact and crush those voids, but just enough to kind of give it a nice smooth surface on top.
Will we see potholes in this material like we do in the traditional pavement or paving?
Well, there's always potential, for potholes, but we will have to maintain the surface as we do any other road. So there's no more potential in this material than there is in any other material.
This has been an interesting day or morning, and technology certainly has taken over the road business, and some of you are going to get to try this out fairly soon. I hope that you've enjoyed our program as much as we've enjoyed bringing it to you. This has been the Transportation Sales Tax Program, also known as Roadways, and I'm Cheryl Harleston.